Now, based on the algorithm that we discussed for searching a particular value on an infinite number of sorted values, let's just go ahead and implement the solution. So here I will not be writing each and every line of code. I explained the algorithm already. It is exactly similar to the exponential searching algorithm that we have already implemented, right? So here I have basically I'm going to copy the implementation that I have already done, and I'm going to paste it into the new file that we have created. And after that, we will go ahead and make the necessary changes so that we will have the solution for this specific problem. Now immediately, once we copy paste this here, we are seeing some issues. These issues are nothing but indentation issues. So let me just fix them. And here we also need to import the math library. Remember that I can directly create the object of this exponential search.py class, whatever class exponential search class we have, and I can reuse it, but I just wanted to copy paste and show you the difference so that you will have a better understanding. Now here internally this while loop indentation is also missing, so let me just realign it back. Okay, so that is the implementation, and here inside the main function we will directly call the exponential search function, and we will pass whatever the array that we have gotten and whatever the value that we have gotten from the user. So no change is required as part of the solution for this problem. But remember that while implementing the exponential searching algorithm, we did not consider an infinite array. That is the reason why, to handle the corner case where our search range is not going beyond the last value that we have inside the array, we have basically put some checks on the size of the array in the range deciding code, as well as in deciding the end index for the binary searching algorithm as well. But here, since we are going to get an infinite number of valued array, we can remove these checks as well, and our logic should work absolutely fine. But I will not be removing these logic. I will still keep them in place as is, because it is a better readable code, and it will basically give you corner case implementation as well. That is the reason why I'm not removing them. I'm just going to keep them as is. Okay, now to test this, obviously we will have to create an infinite number array and pass it as an argument. That is not possible to create. That is the reason why whatever the array that I have created itself, I'm going to consider it as an infinite number of valued sorted array, and in that array we need to search for the value 20. So I have created the object of our class and called the function, and in the end whatever the index that we are returning, we are printing that. So here I am searching for the value 20, and 20 is there inside the array. So if I run this code, let's see what is the output that we get, which is 12. So here this 20 should be at index 12. Let's count the index. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 20 is at index 12. And similarly, to search a non-present value, it should return -1, and -1 is what we have gotten. For example, here we have passed 9. 9 is present, right? So if I run this, see the index we've gotten is 5. At index 5, we have the value 9. If at all, if we pass 8, which is not there, we run the code once again, see we've gotten -1. Similarly, let's just pass -8. -8 is also not there. So if I run this now, see we've gotten -1. Okay, so in that way, we will basically use binary searching technique for finding the value in an infinite numbered sorted array. Remember that as soon as you read the problem description, you will never think that we can apply binary searching algorithm in this array, because as soon as you hear it is basically the array has infinite number of values, you will not know what is the end index, right? So obviously, naturally we will not know we can apply binary searching algorithm, but here first of all we will find the range in which the value might be present, and after that in that search range we will apply the binary searching algorithm. Okay, so that's the solution for this specific problem. I'll see you in the next one.